Hello everybody, my name is Philippe and I'm a technical lead at Freed Codes specializing in CFD and other applications. Today we're going to talk about how to use expressions and cell registers to apply localized sources in Fluent. These cell registers and expressions can be set up very easily through the GUI, and I'm going to show you how. To start with, we have a 2D domain where we have a symmetry plane in the middle and a fixed temperature on the outsides. So something on the other edges. So something very simple to start up. So the first thing we need to do is we need to identify and select the region where we want to apply our volumetric heat sources. So here you can select it with pointing mouse, you can select it. That's really up to you how you want to select it. You can select the shape as well. So you can even select the name as well. So here we're going to display it. And here we selected simply 8 cells. We could select more, we could select less. That's completely up to you. As we see here, we could select less or more. That's completely fine. So now we're going to save this and we're going to close. And now we're going to say where we're going to select the region and automatically select it via some tricks. And here the trick is that we need to make an if statement. If we're in the region of interest, so here region 0, return 1. Otherwise return 0. And this will provide us with a binary to know whether we're inside or outside of our region. So once we're done with that, what we can do is we can go to our region area. So the region area, it's a volume integration because by the end Fluent assumes it's 2D, but it's 1 meter deep. So here we're going to make a volume integration of our region flag, so this 0 or 1 statement, on our surface. And we can calculate this volume directly here. It's 0.03 cubic meters. And we can click OK, and that's pretty much it. We have a region area, we calculated it, and now what we want to do is we need also to set up a power input. So for the power input, I put 1 watt for simplicity purposes. And we need to set up now our heat source. And our heat source is our power input applied to the region flag, as we know, 0 and 1, and then divided by the region area. So it's going to be really a power input not in watts, but in watts per meter cubes, and forcing that at the end we're having the power input and not something else, maybe another number that has to be that you come up with. So let's click on OK. And once we've done with that, we need to set up this heat source. So here it's already there in energy. So we need to select the source term here. We're going to click on edit, and we are going to select the heat source. So localized for the next demonstration. And we click on OK. We click on apply. And we close. So here we have our location where we have a symmetry axis here. And on the walls here, we set up a 300 Kelvin fixed temperature as shown here. Okay, so now that we're here, we can initialize our calculations. We're not going to look at any monitors, we're just going to let it converge. I'm pushing a little bit the convergence further because it's a 2D case, and it's to minimize the error as much as possible, but we don't recommend to go as far as I'm going now. Anyway, so now that we've initialized, we can run the calculation. And we're going to wait a couple of minutes. So now our calculations are converged. So we're going first to check if our fluxes are fine. So let's calculate the heat transfer. And we're finding out that our heat source was 1 watt and the error is 1.410 to the minus 8. So completely negligible with regards to our calculation. And we can have a quick look at the contour of the velocity that we can see here. And where, let's say, the flow is accelerated really at the location where we have our heat source. And in a similar manner, the contour of temperatures is shown here, where temperature increases where our source is. So everything makes physical sense. And this is actually the key and the most important thing here. So now that we've done that, we can think, well, can we do it differently? And the answer is yes, we can do it differently. We can, instead of using cell registers, we can use expressions only without the cell registers. And I'm going to show you how now. And to do that, what we have to do is roughly the same. So we need to make a local flag. This local flag is a bit more complicated, but by the end, it is the same representation. So it is an if statement, and that is, let's say, blocked by if x greater than minus 0.03, if x lower than 0.03, and if y greater than minus 0.03, and y below 0.03. And again, it returns 1 if it's true and 0 if it's not true. So we can click on OK here. And actually, maybe what we can do at this time, it is we can show our local flag here. And it shows here really the location where it is set. We can close. And what we can do then, so we have our region flag. Now we need to calculate the area again. And the area is the exact same thing. We need to calculate, of course, here it's volumetric as I highlighted because it's 2D, and Fluent interprets it as 2D with 1 meter thickness. And here we have the local flag, and we can again calculate the area as well of the volume. And that's pretty much it. Now, just for us to know, we can try maybe with 1 now to calculate the volume of our whole infrastructure. Okay, and we're going to go back with our local flag. And here with auto completion, and we can refresh the value and click on OK. And now, so we have our heat source local, so it becomes the exact same thing, except that instead of using a region, we're using our defined square or our defined expression. So strictly speaking, this means that you can make way more complicated expressions with this. Of course, with more complicated expressions come way more complicated calculations. So here we can anyway calculate our power input. So our power input is provided. We put the local flag, the local area, and we click on OK. We can now go to the surface again, and we're going to edit it. I'm sorry, to the domain. We are going to click on edit, and instead of heat source, we're going to put heat source local, and we're going to click on OK, click on apply, and close. And we can initialize again. And we can calculate. And I'm going to come back in a few seconds with the results. So now that the calculation is converged, the first thing we need to do is to check our fluxes. And here we can check the total heat rate. And here we're finding out that we're losing 1 watt through the walls and we're gaining 1 watt through the heat source. So this is exactly what we're looking for. The error is a 10 to the minus sign, so something completely acceptable. And of course, we can have a look quickly at our velocities, where here is our velocity. We can have a quick look as well at our temperature contour. That is showing a consistent behavior, so the heat up happens and comes. So thank you so much for your attention and for your time. And if you want to know what to do something else or something more complicated, just let us know in the comment down below. We read all the comments and we try to answer them. And of course, don't forget to click like and subscribe. Thank you very much, and until the next one.